All right, here we go with another Venn diagram problem, and we need to find some probabilities here. And we also need to know what we're talking about when it comes to special symbols and terms. Um, Now, number is chosen at random. We've got all these numbers here, and we want to write down what's the P, or what's the probability if I choose one at random of getting something from this set. Well, what is that set? That little symbol here, remember that we've talked about this before, that's the intersection, okay, where two sets meet. So for example, the intersection of A and B, where do they meet? They would just be the values of 5 and 1. Except that we don't have A and B, we've got A and B. That means complement, okay? Complement is what actually we're saying what's not in B. So here we go with my colors, my filler. I'm just going to start with green. What's not in B? Well, the things that aren't in that circle. That. Why did I start with B? B complement. I guess that's where I ended off there. What I want is where that intersects with A. Well, what's an A is, well, this is an A, yes, and this is an A, but that last part was also green. I'm going to change that to, what's this, purple. Purple, that's what we want. That's the, where A intersects with the complement of B, okay? It's in both A and in the complement of B. So we're going to just write that here now. That's equal to, the set is, the only thing that's there is that 4. Okay? Now I'm going to define the rest of these now, aren't I? Yes. Hold on a second. Let's move you up. Get you out of the way there. Yep. And we're going to fill this in white back to what? Yep. Filler. Okay. I need to white, 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 and now look at this one. The complement of A. I'm going to start right there. That are everything that's not in the circle A. That's here and here. Next, the complement of B, which we had just a moment ago. What's not in B? That's not in B. And this is not in B. Now, the last thing was already green, so that's, oh dear, oh dear. We want the intersection. Back up, I was thinking we want the union, U, so that's for everything. I need to start over. It's okay. Starting off with the complement of A, here, here, okay. There's all of these things are going to be part of our answer because we're a union. And then the complement of B is, that's all right. What's not in B? Well, that's here and here. Now, we wanted the union. So this has to be everything that ended up being colored. So now I'm going to take the black here and write out my set equals to all the things that are in the color there are the 4, the 8, 11, 10, and the 12. Okay, the union. We never mentioned the 5 and 1 because the 5 is in both A and B. We want the things that aren't in either. Now finally, this thing here, B bar A, B slash A. Let's reset our colors. White, white, white. Now what this means is we want to know what's in B, considering that we're only looking at A first. What's that mean? Well, first of all, I'm only going to be looking at A. Once I'm only going to be looking at A, now I want to know what's in A that's part of B. That's right there. So that actually wasn't so difficult. We just had to know what that meant. So this is going to be equal to set in there. We have the 5 and the 1. So this is good. We've got our sets defined. Now we need to look at these probabilities. And I'm just going to grab my marker here and write this out. We already know how to do these probabilities. This is equal to a fraction, where on the bottom it's the total number of things. And okay, hang on now. What is the total number of things? My universal set is a set that has all of the things that are in this box here. The 4, 5, the 1, the 8, the 11, the 10, and the 12. These are what I have all together. And then something new right now is I'm going to write this notation, NU. All this means is N is the number of elements that I have in set U. Well, I'm going to count them here. I've got 1, 2, 3, 4, 5, 6, 7 elements. 7. This is going to be helpful because now I'm going over here with my brush, and for my probability, on the bottom is the total number of options when I choose something at random. But I only want something from this set, a intersection B prime. I'm looking up here. There's only one thing in that set. So that's supposed to be a 1. That would be okay for an answer. The chances of getting something in that set, if I grab something at random, is 1 out of a total of 7. If we want, we could change that to a decimal. I worked that out on a calculator, and it's approximately 0.14. Now, this keeps going on and on and on, like 2, 8, blah, blah, blah. But I could say round that to a 3. And then we could say, if we wanted to, as a percent, there's a 14.3% chance that if we choose a number at random, we're going to get that 4. Okay. Down here, B. Oh, follow the arrow, please. Same idea. Equals to. We still have the same total number of numbers. Number of elements is 7. What we want is the number of elements on the top, what we're looking for, that's in the set of the complement of A union the complement of B, which we have up here. How many in there? 1, 2, 3, 4, 5. Well, let's write that out. I've got N of A complement union B complement is equal to, that was a 5, we said. Back to our brush. Oh, brush. Put that here. All right. Equals 2. That would be okay for an answer. If you want a decimal answer, we'd do 5 divided by 7. Or, since we know that 1/7 is 0.414, 2/7, write this up here, 2/7 would be, that'd be 0.286. Let's just make that a row right around a 0.29, right? So 5/7 would be 1, take away this. I'm going to go with a 0.71. How do you feel about that? Hang on a second. We'll make you feel even better in a moment. I'll write that as 71%. 71% chance. Make me feel better, I'm going to use my calculator here. 5 divided by 7 is 0.7142, so whatever, it's 71%. Good with that. Finally, the last one is, what's the probability of getting something in B, given that we're already only looking at set A? Well, we talked about what that meant, and we already got the answer, what that means. On the bottom, wait now, the total we're looking at now is the total number that we have in set A. In set A, we have 1, 2, 3 elements, 3 numbers. That's on the bottom. Out of that, how many are in set B? Well, we wrote that over here. We've got the 5 and the 1. That's 2 numbers. 2. Do a better job. 2. Okay, that's okay as a fraction. We'd be happy with that. But if we want, we can change it to a decimal. Again, we have a repeating decimal, 0.6666666, so on. You get it? Let's just write 0.66. I'm going to round that to a 7. Or we could also write that as 66.7%. All right, then. We've solved some probabilities by looking at Venn diagrams and understanding what we meant by each of these terms: intersection, union, and complement. And just, again, what we understand about probabilities. Hope that helped. Thank you for watching, and have a good morning, afternoon, evening, whichever time of day it is for you now.